Seagrass plants are unique marine flowering plants that form underwater meadows in shallow coastal waters across the globe. Unlike seaweeds, which are algae, seagrasses are true vascular plants with roots, stems, leaves, flowers, and seeds. They play a critical role in marine ecosystems and are considered one of the most important yet underappreciated habitats on Earth. Botanical and biological characteristics. Seagrasses belong to four main plant families: Zosteraceae, Hydrocarataceae, Cymodocea, and Rupiaceae. There are about 60 species of seagrasses distributed worldwide. They evolved from terrestrial plants approximately 100 million years ago, adapting to life in saltwater environments. Seagrasses have rhizomes, underground stems, that help them anchor to the seafloor. Long, narrow leaves that sway with the current. True roots for absorbing nutrients and stabilizing sediments. Flowers and seeds, which distinguish them from algae. Most seagrasses reproduce sexually, through pollination, and asexually, through rhizome expansion. Underwater pollination is unique and occurs via water currents, a process known as hydrophyly. Habitat and global distribution. Seagrass meadows are found in shallow, sheltered coastal waters, usually at depths of up to 10 meters, although some species can grow as deep as 60 meters in clear waters. These meadows exist on every continent except Antarctica. Major seagrass regions include the Caribbean Sea, the Mediterranean Sea, the Great Barrier Reef, the Indo-Pacific region, coasts of North America, Europe, and Australia. Ecological importance. Seagrasses are keystone species in marine ecosystems. Their presence enhances biodiversity and environmental health in numerous ways. A. Habitat and nursery grounds. Seagrass beds offer shelter and breeding grounds for hundreds of marine species, including fish, example sea orzes, snappers. Invertebrates, example sea urchins, shrimp, crabs. Endangered species, example dugongs and green sea turtles. B. Erosion control. The dense root systems bind sediments and stabilize the seafloor, reducing coastal erosion and improving water clarity. C. Carbon sequestration. Seagrasses are powerful carbon sinks. They can capture carbon dioxide, CO2, from the water and store it in their roots and surrounding sediment for centuries. This process, known as blue carbon sequestration, is more efficient than tropical rainforests per unit area. D. Water quality. By trapping sediments and nutrients, seagrass beds filter and clarify coastal waters, supporting healthy marine environments. Economic and cultural value. Seagrasses indirectly support local economies through fisheries. Many commercially important fish species spend part of their life cycle in seagrass habitats. Tourism. Clear waters and rich marine life associated with seagrass meadows attract divers and eco-tourists. Shoreline protection, preventing erosion and protecting property from storm surges. In some cultures, seagrass has been used as fertilizer, roofing material, or livestock bedding. Threats to seagrass ecosystems. Seagrass meadows are declining globally at an alarming rate, with an estimated 7% loss per year. Major threats include coastal development, harbors, marinas, dredging. Pollution, nutrient runoff, oil spills, plastic. Boating activity, propeller scarring. Climate change, ocean warming, acidification, rising sea levels. Overfishing, disrupts balance of ecosystems. These pressures reduce seagrass cover and degrade water quality, impacting all organisms that depend on them. Conservation and restoration. Efforts are underway globally to protect and restore seagrass habitats. These include marine protected areas, MPAs. Replanting initiatives, using seagrass seeds or plugs. Public awareness campaigns. Sustainable coastal development policies. For instance, the United Nations Environment Programme, UNEP, and various NGOs promote seagrass mapping and restoration as part of ocean conservation. Interesting facts. Seagrasses can photosynthesize underwater, requiring sunlight just like terrestrial plants. Posidonia oceanica, a species native to the Mediterranean, can live for thousands of years, with some meadows aged over 100,000 years. Seagrasses are one of the few flowering plants that can survive full salinity and are fully submerged in marine environments. A single square meter of healthy seagrass can produce up to 10 liters of oxygen per day. Seagrass meadows store about 10% of the ocean's carbon despite covering only 0.1% of the seafloor. Conclusion. Seagrass plants are vital to marine ecosystems, coastal protection, biodiversity, and climate regulation. Often overshadowed by coral reefs and mangroves, their ecological value is immense. Preserving and restoring seagrass meadows is essential for a sustainable and resilient future for coastal communities and marine life alike. These underwater meadows are silent heroes of the ocean and deserve global attention and protection.